Okay, so this is our review video about significant figures. Again, maybe you have done this in class, maybe you haven't talked about these in class, maybe you've talked about it a little bit and this is supplementing. Okay, so let's have a little reminder of what a significant figure is. And if you hear us call them sig figs, it's the same thing, it's just easier to say. Okay, so a significant figure, or a sig fig, is the guess figure. So it's going to tell us about accuracy or precision. Precision. Okay, so this is going to tell us about the instrument used to measure. Okay, gives info about equipment. Okay. So, for example, if I give you something that says, I measured the distance from here to the end of the classroom, and it was 45.75 meters. I have no idea if that's right. You can assume that whatever I used to measure, the meter stick, my feet, whatever it was, that it gave a tenth of a meter. Okay, so I had hash marks. I'd had hash marks all the way up to a tenth, and then I noticed that the last one was right in between 0.7 and 0.8. So I guessed a half. Okay, so this tells me that this is my guess digit. And you get 1. Okay, so if I get a guess digit and I say, okay, how many significant figures does this number have? Well, we can count 1, 2, 3, 4 significant figures, or SF for short. Okay, it's when we get into zeros that's a little bit tricky. All right, let's talk about some of the sig fig rules. Okay, so when we talk about zeros, it gets a little confusing. If we just use integers, it's really easy. You just count the number of integers. But with zeros, there's some rules, there's some tricks. Okay, so for example, 0.00682. If it has leading zeros, they're not significant. Okay, meaning if there's all the zeros before the integers are not significant. Therefore, 6, 8, and 2 are the only significant figures here, meaning we have 3. Okay? So whatever instrument we got this number from, it measured to the 10,000ths. Okay? So pretty little. And then we guessed the 100,000ths. Okay? Let's look at a different one. What if we had 1.072? Well, now that 0 is significant because it's not a placeholder 0. It's actually part of the number. So again, whatever instrument we used here measured to the hundredths, and we guessed the 0.002. Okay, so this one has 4 significant figures. If we have something where we just are given a whole number with some trailing zeros at the end, and there's no decimal, none of those zeros are significant. So for example, with 300 by itself, no decimal, has 1 significant figure. Whatever instrument we used, we had to guess the 3, right? Because it's the first integer. So we have 1 significant figure here. But the second we add a decimal, now all 3 of those numbers are significant. That decimal tells us that we could measure the tens, and we guessed the ones. Okay, so we guessed that that was 300 on the dot. So all 3 of those numbers are now significant. Let me throw one more at you. What if we said 300.0? What do you think? Pause the video and think about it. How many significant figures did you come up with? I came up with 4. Okay, why 4? Well, because by adding this decimal, we understood that our measurement tool measured to the ones, and we guessed the decimal between the ones. So maybe whatever we said, we said 300, it said 300, 301, 302, 303. We had those hash marks. We had to guess that it was 300.0. Okay. All right, so when it comes to significant figures, we have to have some rules when we do math, right? So there are rules when we add and subtract, and then there are different rules for multiplication and division, okay? So when we add and subtract, the rule is we're going to round to the least number of places. Round to least number of places. Meaning, if you add 25 plus 3.758, the least number of places is right here. Okay? It has nothing to do with sig figs when you add and subtract. So this number is going to be 28.758, but we're going to round to 29. Okay? Because we can only have the least number of places. Okay? But when we multiply and divide, we're going to round to the least number of sig figs. Okay? These are important things. This is also on your Haiku page. There's a at the front page, the first chemistry page, there is a whole sheet of math rules, but I like to work them out a little bit. So what if instead of adding and subtracting, we said, okay, we've got 20 times 2.47, okay? This has one significant figure, and this has 3. We have to round to the least significant figures, least number. So 20 times 2.47, that is 49.4. But since we only have one significant figure, I'm going to round that to 50. Okay? You have to pay attention to these rules. Throughout the year, it's really important for you to pay attention to significant figures, okay? We're going to have some quizzes, we're going to have some tests where I'm going to be looking to see whether your significant figures are accurate or not, okay? All right, so review. Why do we care about sig figs? It tells us about the precision and the accuracy of whatever was used to measure. You cannot inflate that or deflate that. Okay, in chemistry, we want to know. We want to know, did it measure to the hundreds? Did it measure to the thousands? Did it measure to the tens? Right? And that's really important once we start using some of this lab equipment. Okay, so how do we decide what's significant or not? There are some zero rules. Okay, so leading zeros, not significant. Embedded, so if they're in between integers, they are significant. It's the trailing zeros that are kind of confusing, right? They are not significant unless there's a decimal. Okay, so try to remember that. Okay, when you add and subtract, it's the least number of places. That's where you round to. When you multiply and divide, it's the least number of sig figs. Sometimes those numbers are the same. Sometimes they're not. Okay.